Okay guys, so we will look today at building a decoupled architecture in the AWS solution architect. So the first thing we want to understand that the cafe architecture now supports hundreds of thousands of users. However, it is difficult to make changes to one layer of the application without affecting the other layers. And this is basically take us to decoupling your architecture. With decoupling, we normally refer to a tightly coupled component. But what we really mean by that? In tightly decoupled component, the idea that if you have a web application and this web application, for example, take a request from a web server, Amazon Route 53, then that web tier will also send a request to the application tier, and the application tier will normally speaks with the DB tier. Now, what is the problem with a tightly coupled component? If one of these components crashes for any reason, for example, this application tier or application server crashes, then the both web tier application and servers, they will be not functional. And this means we have to maintain the application and the web tier. To resolve that, we need to decouple them by inserting a third layer in between them that basically make them totally independent of each other. So to resolve this issue, guys, we can mainly make and increase our application availability and scalability and reliability by decoupling those components. So we can add more resources to the application tier, but even so, with that is not going to fully help us to achieve fault tolerance, but it will achieve a high level of scalability. So there is multiple forms of system coupling. There is application level coupling, which means we are going to run the coupling or the component in the source code are tightly coupled. So inside the application itself, there is pieces of those code, a function that needs and wait for the result calculated by another component or another piece of code. There is also platform coupling. When they build that application designed to run in a Linux operating system or in a Mac OS operating system, or even it is tightly coupled to Windows operating system or to .NET framework, for example. In this case, you have only the choice to run your application in that kind of operating system. And we call this a platform coupling. There is also a spatial coupling. And those components, they are mapped and managed by a specific topology, and they can only run in that spatial type of environment, whether at the protocol level or at the communication level. And a good example of this is the novel or the Apple network, the old Apple network, the APA net, which we don't use it today, or when you have an application that only accepts, for example, SSL and HTTP and HTTPS, and in this case, you need to have, for example, a classic load balancer to deal with this kind of application. And there is runtime coupling. With runtime coupling, once the application is executed, that application requires us to have a specific environment like the Java virtual machine. And that Java virtual machine needs to be installed in the web browser before that application can do anything. So in order to make our component loosely coupled, what we could do is to introduce a third layer. And that third layer, we normally use an elastic load balancer. And this elastic load balancer will help us to mainly decouple the web tier from the application tier. So for example, when users try to access our resources, that will go to the load balancer, and the load balancer will distribute this evenly, will distribute traffic to all web tier. In the same way, once a web tier needs to speak with the application tier, this will go to the elastic load balancer, and the elastic load balancer, and in this case it will be an internal elastic load balancer, will forward the request to the free machine that they have less and more capacity to handle the request. In this case, if we do this kind of scenario by introducing external load balancer and internal load balancer, we are going to face high flexibility. If one of these machines will crashes, this will not impact the web tier at all, because the request could go to the healthy target, and unhealthy target might be replaced using an auto scaler. In this section, we are going to look to a new service to us, which is the Amazon Simple Queuing Service, or SQS. In SQS, it's a fully managed, highly scalable service that we have in AWS Cloud. And the concept of a queue in computer science is very simple. It is the same queue you use when you go to, for example, to the ATM to get some cash. A first guy in the queue, he will be the first guy to reach the ATM. That's why we call them in a queue. Now, in computer science, we always use those queues architecture to handle multiple processes when they all need to be processed one by one. In a queue, we have a content producer and we have a content consumer. What we mean by that? Once I publish my video, I produce a content, and you will be all subscribed, for example, to my channel, and you will get a notification that there is a new content published. So because you are a subscriber and you want to see those videos or my classes, you are going to get a notification that there is a new content added to that class, and you will consume the video. In computer science, you can imagine most architecture depending on this fact. There is one machine, for example, an EC2 generating PDF, and another machine wants to take that PDF and convert it to document, consume that document. How we can make sure that both they can work together and without any delay or bottleneck or even overflow buffer? The simple solution for that is to enforce the producer to generate the document into a queue, and those queue will be processed by the consumer one by one in a first in, first out basis. So the first PDF placed in the queue is going to be the first PDF converted to document by the consumer. We call these first in, first out queue. Now, how you can do the same architecture in AWS and you implement a first in, first out behavior? You need to use a service which is called SQS. SQS is a fully managed messaging queuing service that it uses the pull mechanism. Messages in SQS are encrypted and stored until they are processed. So once the EC2 generates a PDF, that PDF message will stay in the queue until we get somebody to process that PDF and convert it into a Word document. They act as a buffer between the producer of the content and the consumer of the content. You have a guy who would produce, for example, 10 PDFs every second. That's the first EC2. And we have as well another EC2 which reads 5 PDFs every second. In this particular case, that PDF generated by the first EC2 instances will not be able to process them by the second EC2 instances on time. So the consumer in this particular scenario is more slower than the producer. This will cause an overflow and a bottleneck. You will have multiple PDFs basically wasted, unprocessed, or even unseen. To resolve that, what you could do is to put a queue. And in that queue, all the PDF generated by the producer will be placed on the queue. And then the guy, which is the consumer, he will process those PDF in his own pace without affecting the work of the producer, without creating an overflow, and without creating even a bottleneck between the consumer and the producer. With Amazon SQS, you can asynchronous processing to get your responses from each step quickly, and you can handle performance and achieve high level of service requirement by increasing the number of job instances. So for example, instead of having one EC2 generating PDFs at 10 every second, you could have 2 EC2s reading from the queue. Each of those EC2s can process 5 PDF a second. In this case, all the PDF that are generated from the first producer will be consumed and processed by 2 EC2s instead of 1 EC2. And this is what we refer to, guys, the horizontal scalability, where you multiply the number of machines to process those files. Also, with loosely coupling inside Amazon with Amazon SQS, you can have an easily recoverability from failed steps because the messages will remain in the queues until they are processed. The general use cases for SQS, you can use them as a work queues, buffering and batching operation, request offloading, and trigger Amazon EC2 auto scaling. Now in Amazon, there is two types of queue. There is the standard queue and there is the first in, first out queue. It's very important for you guys to know that these are very important for the solution architect exam. Why? Because they want you to know the differences between a standard queue and a first in, first out queue. In a standard queue, it will guarantee that you have at least once delivery. So the message or that PDF will be delivered to one EC2 at least one time. The second, it is best effort ordering, which means if the first EC2 instance generated PDF1, then it will generate PDF2. It's not responsible or it's not mandatory that PDF1 will be processed before PDF2. It might be the order, not really important, and we call this in computer science best effort services. Now the throughput of the standard queue is unlimited or nearly unlimited, which means you can place large number of messages and SQS will be highly scalable to process them. Now what about first in, first out queues? From the name, we can understand that they will be messages will be delivered. The messages will be delivered in order. So the first PDF always processed before the second PDF. The second difference is give you an exactly once processing. So it can guarantee that the message will be processed by the consumer at least one time. In the first one, it will guarantee that it will deliver the message one time. In first in, first out queues, we have high throughput, not nearly unlimited. So the throughput and the volume of the messages will be much higher in first in, first out queues. In Amazon SQS, it gives you three major features, and those are also very important for the solution architect exam. The first one, we call it the dead letter queue. In the dead letter queue, any message that remains in the queue in a time frame and never been processed, you can place them in a dead letter or in another queue where all these messages, unseen messages that maybe for a technical error or some issues in the program, we couldn't process them. So you could have a look to them again or process them by another software or another EC2 to handle. The second feature is the visibility timeout. You can specify how much time each message should remain unprocessed in the queue. And after that time expired, the visibility time of a message, for example, 5 minutes. After 5 minutes, if the PDF never been processed, you can place it in a dead letter queue or ignore it totally or delete it from the queue. Depending on your application architecture, you can set up this based on the requirements you want to achieve. So for example, if this is a financial transaction, you want to make sure that this transaction should be processed within the first 30 seconds. If it's not a process, decline it and go and generate another financial transaction. The third type is long polling. With long polling, we can, for example, if the producer in our example generate 10 PDFs per second and the consumer now can read 2 PDFs per second. This means that the producer in this case will generate more PDF than the consumer can handle. And this means that the consumer needs to wait for a long time to go back to the queue and read the next process or the next PDF, which will take him a long time to pull the message. So we are telling SQS now, we have a very slow consumer. Give him all the time to finish everything he has before you do anything, before you delete the existing messages or place them in a dead letter queue. Now, what are the message lifecycle in Amazon SQS? The first thing you do is to create the message, and that message will be placed in SQS server in the queue. The second, the message will be picked by the consumer and it will be processed at will. And this basically will start the timeout for the visibility, how much the message will remain to the queue, in the queue. So after we're setting that visibility timeout and that timeout started, this means that message will be removed from the queue once the visibility time is out. In the third step, the message gets deleted by the consumer after it is processed, and in this case, a new message will be processed by the consumer. And this is a good example how you can use Amazon SQS to decouple a web tier from an application tier and database tier. So you can see here we have an elastic load balancing, forwarding the request to multiple web tiers. Those are, let us keep the same example. They generate each one of them a PDF file. Those PDF file will be placed on a queue, and that basically will put them all in SQS orders. Any process order will go to the did letter queue, and all the order that will be picked by the application tier will be deleted from the queue and processed by the application tier. The use cases for SQS, they normally use them for service-to-service communication. When you have, for example, a mail service, and that mail service speaks, for example, with authentication service. When you have also two items which needs to work with each other in a synchronous way, which means the processing time or the time clock of the consumer is totally independent from the time clock of the producer. And you can look to this in a very simple example. Maybe you have an EC2 machine that generates some content between two different time zones. One time zone in United States and another time zone in Ireland. Both EC2 instances will never be live together at the same time. One EC2 in Ireland, one EC2 in North Virginia. In this case, the generator of the content will place it in a queue, and later on, when the Irish EC2 instance came alive, we'll go to that queue and fetch the first message in the queue. And then when you have like a state change notification. And state change notification is very important to deal with in computer science because, for example, if the temperature of the room change, let me know. This is what we mean the state change. Behavior of our software change due to any information or any event. This is meant to trigger another process to handle those new changes or even unanticipated changes or unforeseen one. And this is very important because we use a change status as well in autoscaling. If you remember what we did when we have autoscaler always look to your infrastructure, and if there is a change in the CPU level, it will add or remove machine. So you can place those changes or events in an SQS, and that SQS queue will be used to trigger another service or to trigger another action. The second service that we use normally for decoupling is called the simple notification service. And the simple notification service now work indifferent. In the SQS, you normally have a consumer publishing content and we have a producer producing content. In the SNS, in the simple notification service, the story is a bit different because you have a publisher. He will put and place a new content in a general topic. And there is multiple processes interested to be notified once a new entry or a new item added to that topic. We call this publisher subscriber. So imagine yourself, you are a subscriber to a news feed. A subscription to a news feed is what we call in computer science the publisher subscriber model. So once there is a new event or a new article published in, for example, in the financial market, and you have some interest to subscribe to all the latest news about Bitcoin. Once there is a new event about Bitcoin, you will be notified. It's totally different from the previous case when we say there is a publisher generating files and another EC2 instance needs to consume those files. Here, you are a publisher-subscriber model rather than you pull the content yourself. And I will tell you now the difference between SNS and SQS in more details. So Amazon SNS is a highly available, scalable, secure, and fully managed publisher-subscriber service. You can use a push mechanism. Now remember guys, here in SNS, we do have a push mechanism. So the publisher push the message and the subscriber will get the message. He will be notified. It supports as well encrypted topic using customer master key, and this is an exam question. Pay attention to it. Now there is many transport protocol. You are a subscriber to a specific publisher topic, for example, Bitcoin. You can get notification about the latest news in Bitcoin using your email, or even it can send you an HTTP or HTTPS, which you can webhook to another tool, like for example, Slack or any team notification service that you have in your team. Or it can send you an SMS to your mobile phone, or even it can place the new message in another queue, which is in this case will be an SQS. And the last thing you could do as well to wire SNS with AWS Lambda function, so it will trigger a Lambda function. The use cases for Amazon SNS, that it will be used for the application and system alerts. It will be used for push email and text messages, which is what we call normally in this business the push notification. The push notification, without your mobile going to the head of the queue and pulling the latest content, it will receive a new notification about a latest news that happened in the topic that you are subscribed in, like Bitcoin. And the last thing is, for of course, mobile push notifications, and all of you must be familiar what a mobile notification is. When you deal with SNS, you have to consider a single published message is going to be delivered. There is no recall option. Once the message leaves SNS, you can't recall it. You can't change your mind and say, please return it back. There was an error in the message. I need to get the message back and edit it. Also, order and delivery is not guaranteed. If you send multiple messages in SNS, like this is M1, M2, not necessarily they will be received by the subscribers in the same order, or sometimes they might be not delivered. So when that message is sent to all mobile devices, if one device was off, he will never get the message. And you can have a retry policy for a messaging protocol, which is for the delivery protocol, which means if the message is never delivered, you can retry, let's say, in a grace period of time or in a period of time, in order just to make sure that your notification will be received by the users. And this is a good example how we can wire both together and to build a highly decoupled application. We have an application, and that application is a mobile application. We have users uploading images to S3 bucket. This will generate an event, and that event will be sent to SNS topic. You can call this topic a new image uploaded. Once that topic receives a new message, that will send a new message to 3 different queues, SQS queues. So in this case here, we have the SNS is the producer of the content. We have the uploading of the image to S3 bucket is the publisher. So the publisher put a new content into S3. So basically will generate a new content by SNS into the 3 different queues. And one queue will be used to take that file and convert it to thumbnail. The second queue will be used to basically resize the image into a mobile format. And the third queue will resize the image to make it more suitable for web application and desktop. Each queue is consumed by a set of EC2 instances running behind an autoscaler. So each EC2 instance will go to the SQS queue and read the message in the queue, pull it, process it, change it to the desired format, and then place it in a target bucket. Now, what are the differences between SQS and SNS? And this is seriously important for your understanding of both services and for the solution architect exam. Remember that the SNS is a publisher-subscriber model. There is one service generating content to place it in a topic. That topic has multiple subscribers. But in SQS, you have one service generating content and another service consuming that content. Now, the delivery mechanism in SNS, the subscriber need to do nothing to get the message. Your mobile phone receives the notification without doing anything, without requesting or calling or sending or calling a procedure or an API. It will receive the message because it was subscribed to. In queuing, it's active polling, which means your mobile device, if he wants to get the latest content, he needs to go to the queue and pull the head of the queue. Now, the distribution model in SNS, it's many to many. Many people could publish latest news about Bitcoin, and thousands and millions of users, maybe they are interested to hear about Bitcoin, so they will subscribe to this topic and they will get it. They will get it, those latest news that are generated by multiple people. In SQS, it's one-to-one. So keep this in your mind. SQS is not handling one-to-many. It should be one-to-one. One guy producing content and one guy consuming the same content. And the message persistence in SNS, the message once it's leave the SNS service, it will no longer be available. It will be totally deleted from the SNS services. But in SQS, the content of the queue could persist. You could place them, delete them from the queue, yes, but you could place them in a dead letter queue as well. Or you can change the visibility time of that message. So in this section, we understand the importance of SNS and SQS to decouple your application. And let us look to a more advanced architecture, how we can make a highly decoupled application. So we want to look, for example, to a high professional service. It's called Amazon MEQ, which is another queuing application or another service for queuing and communication when you have multiple producer and consumer. Amazon MEQ is a managed message broker service for Apache Active MEQ. This is a very famous product in the industry, and this basically the most compatible service for that service in AWS. Amazon MEQ, it can be used for the provisioning, setup, and maintenance of Active MEQ, and can simplify the message migration, specifically when you have an Active MEQ on a prem data center and you want to take all that messages from that broker also to your cloud infrastructure. It is compatible with the open standard API and protocol, and this means it supports multiple different flavor of Active MEQ. So you have, for example, STOMP, MEQTT, and WebSocket, and also JMS and NMS, which is Java, for example. This is for WebSocket and SSL layer. And MEQTT is also a very famous protocol. We use it in a very popular product in the industry called RabbitMQ. With Amazon MEQ, you can use it as to migrate between your message broker that you have on a premises data center and your infrastructure in the cloud. Now, the features and the differences between MEQ and SQS and Amazon SNS, you can summarize them in this table. For MEQ, you normally use it for application migration. What we mean by that? Maybe you have a smart home setup and there is multiple sensors, and those sensors, they keep sending you data from your smart home into a queue. Let's say it can be a Raspberry Pi, maybe you have it running in that home, and you want to upload those messages, the latest sensory data, to AWS. In this case, you want to link the MQTT that you have in the Raspberry Pi in your home with the infrastructure that you have in the cloud. Maybe you have an EC2 machine where you want to display all these sensory data in a dashboard, in a smart home dashboard. Now, Amazon MEQ can be used with multiple protocols, like the one which support Java or WebSocket, but SNS and SQS, they are HTTPS only. The second difference is that the SQS and SNS, they born in the cloud. They never been on a premise data center before. And in Amazon MEQ, you pay per hour and the gigabyte. but in SQS and SNS, you pay per request. Besides, this is a message broker, which means it is operate as a publisher-subscriber model. It also can do publisher-subscriber model and consumer and producer model. Both it does support by Amazon MQ. Now with SQS and SNS, SQS cannot do publisher-subscriber, but it can do publisher-subscriber in Amazon SNS. So by this, we finish module 12, which is building decoupled architecture. And I advise you now to keep in your mind that in this module, we need to understand those three services. Most likely, you will get an exam question about SQS and SNS. We have differentiated between tightly coupled and loosely coupled component. Remember, loosely coupled architecture are preferred. Identify how Amazon SQS can be used and employed to decouple your infrastructure, and also how you can employ Amazon SNS, and you can also use Amazon MQ to link your on-premise data center with a cloud infrastructure and